Okay, so in this class, we are going to study about arch and structural analysis. Arch is nothing but curved members. Like if we are talking about a beam, then these are straight members. This is an example of simply supported beam. Similarly, arch means curved members. So the beam will be curved with simple support condition or any kind of supports. Okay. Now this is one arch, example of one arch. Now we are going to classify different types of arch. Okay. Now if I classify based on shapes, based on the shapes, if I classify arch, there are different types of arch. One is semicircular. I will write all the. So there are basically five types of arches based on the shapes. The first one is semicircular, means this will be a semicircle, and this is an arch with any type of support condition. Segmental means not the full semicircle, a part of the semicircle. Means this, the figure can be like this, not a full semicircle, just a part of it. Parabolic means the shape of a parabola. Elliptical means shape of elliptical. parabola किस तरह होता है, कुछ इस तरह होगा, है कि नहीं. एलिप्टिकल क्या होगा, ओवल शेप होगा. पॉइंटेड मीन्स कुछ इस तरह होगा, this and this is one. There will be a point at this point, okay, with some support condition. So these are the different types of arches based on the shapes. Now I will classify the arch based on number of hinges. We know already about hinges. What do you mean by hinge? Hinge where rotation is allowed. Only two support directions will be there, isn't it? Movement will be 0. So based on the number of hinges, there are three types of. One is three-hinged arch. Three-hinged arch किस तरह होगा? At the two supports there will be, if this is an arch, there will be three hinges. Hinge at one support, hinge at another support, and there will be a hinge at the highest point of the arch. We will be studying more about this. Okay, so this is a three-hinged arch. Another is two-hinged arch. So in two-hinged arch there will be hinges at the supports only. Here one hinge and here one hinge. Okay, there can be any type of supports. Okay, so these are hinges. So another is, the last one is fixed arch. Fixed arch. So there is no hinge. Okay, only arch will be there and the supports will be fixed. Okay, so based on the number of hinges, there are three types of arches: three-hinged arch, two-hinged arch, and fixed arch. So let's study about three-hinged arch, which is in our syllabus. So we can study also about two-hinged arch, but if time permits. So three-hinged arch. So in three-hinged arch there will be three hinges. Now let's consider there is an arch with three hinges. One hinge at support, okay, another hinge at another support, and here one hinge. Okay, now let's consider the length is L. Between these two supports the length is L. Okay, now let's name them. This is support A, this is support B, and this point is point C. Okay, let the loading conditions be now. Loading here, W1 is applied here, W2 is applied, another load is applied here, W3. okay, and let the distances be also. This distance is A. Between W1 and W2 the distance is B, and this distance is C, and this distance is small d. Okay, now we have the loading condition in the three-hinged arch. Now this hinge is provided at the highest point of the central line of this arch. Okay, so this will be the maximum height where the third hinge will be provided. Okay, now this horizontal distance between two supports is called span of the arch. Span of arch. Okay, now these two supports can be at same level or can be at different levels. Okay, for now let's study when the supports are at same level. Okay, now when they are at same level, then this maximum height is called as rise of the arch. This is span of the arch and this is rise of the arch. Okay, it can be denoted as capital small h. Okay, so now when as these supports are hinged now, okay, so there will be two support reaction at each support, and this is the internal hinge where moment is 0. Okay, so if I draw with the support reactions, so this is the arch. Okay, here there will be two reaction, one vertical reaction and one horizontal reaction. Here also one vertical reaction and one horizontal reaction, and there is a hinge. Okay, point C. So this is point C, this is point A, this is point B. Now at A, let's consider the vertical reaction is VA and the reaction at VB is VB. Okay, now let's consider the horizontal reactions BH or H, they will be same. How, I will tell you. So here the loading condition is W1, here it is W2, and here it is W3. Now we are considering the both support are at same level and the loading condition are entirely vertical. Okay, now if they are vertical loading only, so this horizontal force H and H must be same, otherwise equilibrium will not be maintained. Similarly, VA and VB are acting upward, W1, W2, W3 are acting downward. Okay, so for maintaining equilibrium, VA plus VB must be equals to W1 plus W2 plus W3. This is one loading condition. Okay, now as we are restricting in the horizontal movement also, the reaction generated at support A must be equal to the reaction generated at support B but opposite in direction, then only the equilibrium will be maintained. Okay, so now when these two support level these two supports are at same level, then it is considered, or we can solve this problem by considering as this is a simply supported beam. Okay, simply supported beam. Okay, we will solve it by applying equilibrium equation in as we applied in case of a simply supported beam. Okay, now this horizontal force or horizontal reaction is called horizontal thrust. Horizontal thrust, THURST. So whenever we are going to analyze a 3-hinged arch, we have to find out the support reaction BA, BB, and horizontal thrust H and H. Okay, and bending moment at any cross section or shear force at any cross section to draw the SFD and BMD. Okay, now as we are considering this as simply supported, then this VA and VB can be calculated by using equilibrium equations. Okay, both VA, VB and the horizontal thrust can be found out by applying equilibrium equation. How? At support A moment is 0, at support B moment is 0, and support C also moment also 0. Okay, now we will try to find out VA, VB and H by considering as the simply supported beam. So first we need to find out VA and VB. So to find that, what we have to do, we have to apply equilibrium equations. How? Summation of all vertical force equals to 0. So V plus VB is equals to W1 plus W2 plus W3. Summation of horizontal force 0, H equals to H. Now moment about point A or point B 0 because they are supports. So if I take moment about point A is equals to 0, then the equation will be VB into the length is L. This is in anti-clockwise direction. The other loading condition will create clockwise moment, so will be equals to W1 into A plus W2 into A plus B plus W3 into A plus B plus C. So we will have, from this equation we will find the value of VB. If we put this in this equation, then we will find the value of VA. So by applying equilibrium equation, we found VA and VB value. Okay, now we need to find out the value of horizontal thrust. For this we have to take moment about point C is equal to 0. If you take moment about point C 0, then we can consider the moment towards left or towards right. So if I consider the left side section, then moment at C point. So due to force VA there will be moment, due to this H there will be moment, and due to this W1 also there will be movement. So due to VA there will be anti-clockwise movement. So VA into this distance is L by 2. So this is L by 2. So VA into L by 2. Other forces are causing clockwise movement, anti-clockwise movement. So this will be equals to H into this distance. We already know the distance is rise or small h. Okay. So this will be equals to the horizontal thrust h into the small h. This is small h. Okay, this force is causing an anti-clockwise movement, plus the moment due to this W1. So W1 into distance is L by 2 minus A. So L by 2 minus A. Okay, so we have already found out. So only the unknown remains here is h. By solving this equation we can find the value of h. If I consider the right side of the point C, so what will be the moment? So VB into L by 2 must be equals to h into h, then plus W2 into this distance L by 2 minus this distance. What will be the distance? This will be L by 2 minus D minus C. Similarly W3 into L by 2 minus D. Okay, so we can solve either of these two equations to find the value of h. Okay, now we have to find out shear force and bending moment at any cross section. Let's consider this is a cross section x and x. Okay, we need to find out the bending moment or shear force at any cross section x. Okay, so let's consider this distance is x. Okay, and we need to find out moment at cross section x, mx. Considering the left part, if I find the moment, what will be the moment? VA into x, VA into x. Okay, this is a clockwise moment. Other forces are causing anti-clockwise. So minus W1 into distance is x minus a. So this is x minus a. Again due to this horizontal force, minus h into which distance? This distance. Okay, at x, what is this distance? Then let's consider this is y. So h into y, m moment at cross section x. So now as both are at same level, we can consider this as a simply supported beam. If I consider this as simply supported beam, there will be two reactions, VA and VV, and other loading condition as it is W1, W2 and W3. Okay, and we have taken the cross section here. This is x and x. Okay, so for this case, if I find the moment at x, what will be the moment? This will be VA into x minus W1 into x minus a, because this distance is a. Okay, so this distance is also a and this distance is x. Okay, now this moment, this is the moment in simply supported beam. This is called beam moment. Okay, this is called beam moment. Okay, the only term not here is h and y. Okay, due to this curvature there will be the height of the height at this cross section which will be coming into this picture. Okay, now this hy, h into y, this term is known as h moment. Okay, so actual bending moment is equals to beam moment minus h moment, beam moment minus h moment, all at x. all at cross section x. Okay, so actual bending moment in an arch will be, if you consider this as a simply supported beam, that is the beam moment minus h moment. So h into the cross section, at the cross section what is the height, we can find out that height to find out this moment. Okay, now this beam moment will be sagging moment. Okay, sagging, so this will be positive sagging moment. Okay, this is positive. However, this h, this will create a hogging moment, so h moment is hogging moment or negative in nature, hogging moment or negative. Okay, so this is all about three-hinged arch theory. Okay, we will be solving some problems also to clarify or better understand the three-hinged arch concepts.